Chapter 6 Spare Parts Management for Process Equipment. Section 1 Overview of Spare Parts Management. Part 1 Definition and Classification of Spare Parts. During equipment repair. To reduce downtime during repairs. Based on the wear patterns and service life of parts. Parts that are prone to wear in the equipment are pre-manufactured, purchased, and stocked in advance. These pre-stocked parts, in certain quantities, are called spare parts. There are many types of spare parts in production. To facilitate management and usage, spare parts are generally distinguished from equipment, tools, materials, and low-value consumables. And spare parts are classified using different methods. There are many categories of spare parts. They can be classified based on technical characteristics, usage frequency, source, management, and more. Part 2 Goals, Tasks, and Content. The goals of spare parts management are: first, minimize production downtime losses caused by unexpected equipment failures. Second, minimize both the downtime and cost associated with planned equipment repairs. Third, minimize spare parts inventory funds while ensuring a reasonable supply. The tasks of spare parts management include: first, establish appropriate spare parts management organizations and necessary facilities. Second, provide qualified spare parts to maintenance personnel promptly and effectively. Third, effectively collect and provide feedback on spare parts usage information. The main work includes technical management, plan management, warehouse management, and economic management. These will be covered in the following sections 2, 3, and 4. Section 2 Technical Management of Spare Parts. Part 1 Content of Technical Documentation for Spare Parts. The first aspect of spare parts management is technical management. First, you need to know what technical documents are available. Examples include self-made records and external spare parts cards, as shown on the slide. The second part covers methods and principles. Determining the types of spare parts to stock is a highly technical and proactive task. The basic principle is to start from the actual situation of the enterprise. To meet the needs of equipment maintenance. To ensure the normal operation of the equipment. To reduce inventory capital. Generally, the following types of parts can be included in spare parts storage. First, rolling bearings, drive belts, chains, leather cup seals, hydraulic components, and electrical components. Second, wear parts listed in the equipment manual. Third, parts that transmit the main load and are themselves relatively weak. What factors should be considered when determining spare parts? First, the type of products and the equipment processing targets of the enterprise. The nature of production and usage characteristics. Second, the quantity of equipment owned by the enterprise, its operating time and working environment. Third, usage and maintenance conditions, repair capabilities, and regional supply status. According to the nature of the spare parts. The storage forms can be divided into the following types. First, finished parts reserve. Second, semi-finished parts reserve. Third, paired parts reserve. Fourth, component reserve. For example, hydraulic loosening plates for reducers. Fifth, blank reserve. Based on inventory control methods. Storage forms are further divided into two types: regular reserve and intermittent reserve. Part 2 Spare Parts Reserve Quota. Spare parts are very important. So, how much should be stocked? This is called the reserve quota. It provides the baseline data for determining spare parts reserve quotas and planning equipment maintenance. It serves as the basis for guiding the production, ordering, procurement, and stocking of spare parts, enabling scientific and economical warehouse management. Next is the key point of this chapter: calculating the reserve quota. It can generally be calculated using the following formula. Inventory, D, equals coefficient, K, multiplied by spare parts quantity, E, multiplied by supply cycle, Z, divided by average service life, C. Since the lifespan of parts is hard to determine, the actual consumption M is often used instead. That is, M equals E divided by C. Thus, the formula becomes D equals K multiplied by M multiplied by Z. Maximum reserve quantity Dmax equals K multiplied by M multiplied by Z. Minimum reserve quantity Dmin equals K multiplied by M multiplied by G. Order quantity equals Dmin plus M multiplied by Z. C is the average service life of the spare parts. E is the quantity of spare parts owned. M refers to the monthly consumption of spare parts. Z is the supply cycle. M is the monthly consumption of spare parts. G is the most economical processing cycle calculated monthly. K refers to a coefficient. Example, shaft of C620 to 1 lathe. 1 piece per equipment unit. The entire plant has 60 units of the same equipment. The service life is 4 years. Manufacturing cycle is 2 months. The most economical processing cycle is 12 months. Calculate the minimum stock, maximum stock, and reorder point. Solution, based on the given conditions, M equals E divided by C equals 1 multiplied by 60 divided by 12 multiplied by 4 equals 1.25, take 1 unit per month. Z equals 2 months. G equals 12 months. Select K equals 1.1 according to company conditions. According to the formula, Dmin equals K multiplied by M multiplied by Z, Dmax equals K multiplied by M multiplied by G. Reorder point equals Dmin plus M multiplied by Z. Then the minimum reserve quantity Dmin equals 1.1 multiplied by 1 multiplied by 2 equals 2.2, rounded to 2 units. Maximum reserve quantity Dmax equals 1.1 multiplied by 1 multiplied by 12 equals 13.2, rounded to 13 units. Reorder point equals 2 plus 1 multiplied by 2 equals 4 units. Section 3, Spare Parts Planning Management. Spare parts planning management is the process in which the personnel responsible for spare parts planning forecast the demand for spare parts and develop production, ordering, and supply plans based on the company's maintenance capacity, annual repair schedule, and market conditions. Part 1, Classification and Basis for Spare Parts Planning. First, classification by spare parts source. Divided into, first, self-manufactured spare parts production plan and purchased spare parts production plan. Second, classification by spare parts plan timeframe. Divided into annual, quarterly, and monthly spare parts production plans. Part 2, Methods for developing spare parts plans. The method for developing spare parts plans is shown in the diagram. It requires going through spare parts demand and identifying spare parts items. Determine the production cycle, prepare the plan, and develop procedures, followed by production preparation, implementation, and other steps. Various factors need to be considered, such as spare parts request forms, production maintenance plans, local collaboration capabilities, spare parts drawings, and related documents. Section 4, Spare Parts Inventory Management. Part 1, Content and Requirements of Spare Parts Inventory Management. For manufactured or purchased spare parts. After storage and record creation, they should be carefully stored and meticulously maintained according to procedures and relevant regulations. Ensure the quality of the spare parts inventory by distributing spare parts from inventory and using statistical analysis of dynamic information. You can identify consumption patterns during the use of spare parts. Gradually adjust the reserve quotas. Maintain a reasonable stock of spare parts. Inventory is generally managed by category. For example, blank spare parts warehouse, electrical spare parts warehouse, mechanical spare parts warehouse, and general spare parts warehouse. Part 2, Verification of Spare Parts Inventory Funds. Spare parts inventory funds are the capital a company uses to purchase or manufacture equipment repair parts. They are also called spare parts reserve funds. They are part of a company's working capital. Currently, there are several methods to determine a company's spare parts reserve quota. First, calculate based on the reserve quota specified in the spare parts card. Second, estimate at 1% to 2% of the original total purchase value of the equipment. Third, determine based on maintenance estimates of typical equipment. How do we assess the use of spare parts funds? This is generally considered through the following parameters. First, spare parts capital turnover rate. It is the average annual inventory value divided by the annual consumption value. Reducing the occupancy of spare parts funds and speeding up turnover has great economic significance. Second, spare parts inventory fund turnover rate. It measures the funds tied up in inventory spare parts and their actual efficiency in meeting equipment maintenance needs. The calculation formula is total annual spare parts consumption divided by the average annual inventory value. Third, capital occupancy rate. It measures how reasonably the funds are tied up in spare parts storage. This helps control the amount of capital occupied by spare parts reserves. The formula is total spare parts reserve funds divided by original total equipment purchase value. Part 3. ABC Management of Spare Parts. Spare parts management often uses the ABC classification method. Class A spare parts typically have a long reserve cycle. It has a slow turnover rate and high importance. The number of reserved parts is relatively small. Usually only 1 or 2 parts, which are hard to procure or manufacture and are relatively expensive. There are more items in Category B. The amount is smaller. Category C has the most items. The amount is the least. This shows the percentage of ABC spare parts in total quantity and total value. It can be seen that Category A has the fewest items, but it accounts for the largest value. This reflects the company's actual inventory status. Items like pump impellers, pump bodies, and pump covers tie up the most funds, and they are the hardest to process. From the chart, it is clear that this is exactly why management follows the ABC classification method. This method is worth learning. Part 4. Spare Parts Warehouse Information Feedback. The spare parts warehouse contains hundreds to thousands of varieties. There is a high turnover rate. Computer management should be used. A computerized management system should be implemented. There are generally the following types of information feedback in the spare parts warehouse. Minimum stock level information feedback. Spare parts inbound information feedback. Capital activity information feedback. End of this chapter. Thank you for listening. Please complete the following assignments after class.